So far we've talked about energy being radiated from the sun to the earth, and mostly that's then just about how much is being received in the upper atmosphere. But because of the atmosphere, we have a situation that we need to consider, being the sort of the surface atmosphere system of the Earth itself. And because of that atmosphere, solar energy received at Earth's surface is significantly less due to a few factors that we'll have a look at here. So it's less than the average incoming solar radiation that we discussed in the previous video. And the reason why that is that some of the energy is going to be absorbed in the atmosphere, and some of it's going to be scattered by the atmosphere as well. On top of that, we also have the issue that Earth's surface is not a black body. And so by identifying that particular aspect, it's not even a good approximation, Earth's surface not being a black body means that it's going to reflect some of that light, or some of that radiation. So there's that factor that needs to be considered as well. The extent to which energy is reflected by the Earth's surface is quantified by a quantity known as albedo. And we'll have a look at how we define albedo. And it's not constant for all surfaces, it does vary. But we'll have a look at the definition first. Now, the definition can get a little bit, seems a little bit wordy, but just sort of trying to clarify the details around what the ratio is that we're dealing with. So it's the ratio of the energy reflected by a surface in a given time frame and that's compared to the total amount of energy that's incident on the surface in that same time. So note that again it's a ratio, it doesn't have any units. And it then basically just sort of ties into different surfaces and how much energy is going to be reflected, how much is going to be absorbed. So you can think of the equation as being A being equal to, and this is from the data booklet itself, so it's total scattered power. So if we think about scattering, same as reflecting off the surface, over the total incident power. So as I said, that's an equation from the data booklet, so I'll just go through and highlight that quickly. And to give you some examples of what albedo is across the Earth's surface, some examples, first of all, if we think about a particularly bad reflector, so a black body, given that it doesn't reflect any, would have an albedo of 0. The ocean doesn't actually reflect all that much either, at 0.06. Snow reflects some, so 0.85. So it sort of seems a bit odd here that we've got the albedo for snow being quite high when it's also its emissivity is quite high as well. If we look at sea ice, and now the reason why we're mentioning sea ice here is that we know that it's melting, So if we've got less sea ice, then we've got less energy being reflected. Urban areas, so sort of areas around where we live, have an albedo of 0.15. Deserts have an albedo of 0.40, and forests, depending on the type of forest, in the textbook you'll see that there's a couple of values that are in the range of 0.15 to 0.25. Across the Earth's surface, the albedo does vary, but annual average albedo for Earth is 0.3. So that's the value that we'll be using for any calculations. It does vary daily, and the reason for that is cloud formations, even latitude, the terrain over which the albedo is being measured, and even the material of the surface in question. So as we saw, sea ice being different to the ocean, being different to urban areas. So lots of different factors that can affect albedo across the Earth's surface, but on the whole, we use a value, the average annual albedo of the Earth being 0.3. One last point to make here as well, Earth's albedo is usually quoted with reference to visible light. So if there are any other albedos mentioned, it would usually indicate that it's not just for visible light, that it does incorporate other parts of the electromagnetic spectrum as well. So that's the next little bit we need to look at in terms of this idea of thermal energy transfer in terms of energy received by the Earth. In the next video we'll look then at sort of the next stage of the process, where we have this radiation being reflected off the Earth's surface, and therefore what happens in the Earth's atmosphere as a result, known as the greenhouse effect.